Hey guys, it's Lily and Min Min. As much as we wish we could be doing an ASMR session right now with some popcorn, we have something of greater value to discuss. A crazy thing that happens in our own bodies. Meiosis. This little thing is actually a huge deal. This process is the deciding factor of having a tiny something called genetic variation. Just kidding! It's a big something, since it's the very reason why everyone looks different. If you ever have come across the thought that your sibling might be adopted by how different they look or act, don't be worried. Meiosis will explain it all, unless you want your sibling to be adopted. But before moving on to this splendid topic, it is always confused with a similar but completely different process known as mitosis. Mitosis' main goal is to duplicate cells, like how they kinda did in the movie Jurassic Park. How although scientists thought it would be a great idea to clone dinosaurs, but the universe was screaming no! This is a terrible idea at them. At the end, almost everyone is dead, because the dinosaurs like, screw it! We're doing our own thing. Besides that, meiosis is what gives us the rip-off sperm Pokemon, Dynamo, and eggs, aka gametes, sex cells that exist in females and males. The sperm and the egg make this thing called a baby from a zygote, but I have a feeling that I already know how that goes, so there's no need to venture down that rabbit hole. But what you don't know is that these eggs and sperm are the very key of variation. A human starts off with 46 chromosomes, a homologous pair of a daddy set and a mommy set. From the daddy and mommy, the kid receives a set of 23 chromosomes from each, explaining how we get the magical number of 46. Meiosis is the process where you take a diploid cell and break it down into 4 haploid cells that have a set of 23 chromosomes and chromatids. From 2 rounds of division, it can be either a sperm or egg depending on the person's gender. A simpler way to visualize this process is to imagine a big cube, and imagine that cube getting broken down into 2 different colored cubes, later broken down into 4 smaller different colored cubes. But before we even touch those cubes, we go through a stage named interphase. We start with a happy cell which has 46 chromosomes. Later, in interphase, it duplicates those 46 chromosomes to have 92 chromatids. While the duplication is happening, the cell starts to grow, becoming bigger. Now begins the nasty divorce of the mom and the dad homologous pair. Starting the papers under the title of Prophase 1, in this stage, the problems only start to arise as the spindle fibers start to peek out, as the nucleus disappears. Next, the homologous pair is joined together, moving away from the original pair, leading to the magical event of crossover. They're exchanging genetic information among each other. This event is what contributes to the variety among siblings, even when they have the same parents. Next stop on the divorce train is metaphase 1. This is where the spindle fibers take full advantage of the chromosomes, attaching themselves like a clingy new girlfriend to the chromosomes, aligning the chromosomes along the equator of the cell, creating an almost straight row of chromosomes. This isn't the end though, as anaphase 1 is the thing that completely separates the homologous pairs, as the greedy spindles pull the once couple away from each other forever. Mommy and daddy will never be back together again. Concluding the divorce papers is the final section, telophase 1, where a dotted line awaits a signature. Telophase ends by forming 2 complete nuclei and a reforming nuclear membrane. The only thing that has survived through this divorce is the relationship of the sisters, as cytokinesis results in having 2 daughter cells form as they rip away from the cytoplasm, each one having 23 chromosomes from each homologous pair. It's like one of those sappy anime tropes where a pair of siblings have to rely on each other since they can't on the world. Like Full Metal Alchemist Brotherhood. This means we go under another round of meiosis, beginning meiosis 2. Sadly, meiosis 2 is about the crippling relationship of the sister chromatids, an even more uneventful process than meiosis 1. We start off by prophase 2. When compared to prophase 1, it's as if prophase 1 is the most delicious piece of toast you ever had with glistening butter. But then prophase 2 comes around, acting more like a bland piece of toast that has been left on the counter for 5 days. And once you take a bite in it, it's all stale and crumbling. No one likes it. As usual, the nucleus envelope dissolves as the chromatins begin to condense, and the formation of spindles appear. The duplicated chromosomes stay among the cell's midplane. The next spell that reveals itself is metaphase 2. In this stage, the chromatids are going to line up like ducklings in a straight single line in the middle, and become attached to the spindle fibers once again. This is where the two sisters get into a fight, having their friendship ruined by anaphase 2. The chromatids are going to be torn away by the spindle fibers, so it will be the centromeres, moving towards the cell's poles, now being considered as chromosomes, finally concluding the entire meiosis process in telophase 2. The nuclear membrane reforms, the spindles disappear, and the two cells have divided, making 4 unique haploid cells. Following close behind is cytokinesis, completely splitting up the cytoplasm, making 4 separate cells. This is the end of meiosis. While there has been destruction between sisters and husbands and wives, it is all for the greater good of variety among families, unless incest happens, but that's another topic. The independent assortment and crossing over created by meiosis is the very thing that